Hi everyone. In this video, I wanted to touch on how to use and when to use averages in forecasting. Now we're going to cover three different types of averages. There are a few others, but these are probably the most popular ones when it comes to forecasting. So let's jump right in. And what I'm suggesting here is that we have some data available to us. So we have 10 periods of data available to us, or 10 observations. This could be weeks, or it could be months, or it could be days. Okay, and then we've got our past sales, so we can see what our past sales have been. And probably the easiest one to start with is what we know as the simple average. And quite easily, it's simple because all of the observations are given the same amount of weight. So if I take all of these 10 observations and I average them out, I'm going to come up with an estimate of 300. So if we were going to try to make a prediction, let me just clear some of this marker out of the way. So if we were going to try and make a prediction here for period 11, one thing we could do is use the simple average and say over time, we typically would sell about 300 units in this particular time period. So we can forecast 300, and it could be that simple. I do think in considering averages, we should always look at the data as well. So let's do that very briefly, and let's look and see what the data looks like graphically. And this should give us a hint, and we'll talk about this at the end of the video. This should give us a hint whether or not the average is probably a good tool to be using in this particular case. Now, you do see that, we start at some levels, we go up, we go down, we go up, we go down, right? It's got this cycle to it, but generally speaking, it is somewhat flat and constant. And that is a good opportunity to use something like an average. It's going to go up, it's going to go down, but it tends to hover around the same values, time in, time out. Okay, so looking at this data, an average could fit this potentially, but we'll talk about some of the limitations of averages in a second. So the simple average, quite easily, all of these values are divided by 10 and we get 300. Now we can use something else called a moving average. And for this particular example, I simply grabbed the last 6 months worth of data. And instead of averaging out all 10, I just averaged out the 6 observations. Now again, in the moving average, the 6 observations, they are all given equal weight. Okay, so 299 is what we come up with. If we add all of those together and we divide by 6, we're going to get 299. Very close to the simple average. And all that moving does is ignore a little bit latter data, right? You're choosing new data. And the way that this would work, let me just clear this out. The way that this would work is over time, you would drop off an observation and then you would capture a new one. So if month 11 data came in here and it was 300, and then, if month 12 came in, we would drop off month 6. We would always be revolving so that, we've got 6 months worth of current data to work with. All right, let's clean this up a little bit here. Okay, now the last one is a weighted moving average. And a weighted moving average applies different weights. Now let me just get rid of this. There's no exact science that says one thing needs to be something else. And you'll see here in a second that I've given some estimated weights to different time periods. So in the weighted moving average, what we're saying is, okay, we're going to take ideas of the moving average, but we're going to weight them unequally, meaning we're going to give them different values in this. And this is pretty common. So what I've got is 3 months worth of data here. And I'm saying, okay, instead of capturing 6 months, let's just capture 3 months. Again, this is the choice of the forecaster and how much or how little to grab. But instead of all the observations having the same value, we're now going to give them different weights. Okay, so you see that the most recent period here, which is period 10, okay, period 10 ends up having the bulk or the majority of the weight in this particular forecast. And really, the math is pretty simple here. All that we would do is we would take period 10's sales at 340 and we would multiply those by 0.7, okay? and that would give us a value. Then we're going to do the same thing for period 9. We're going to take that 320, and we're going to multiply this by 0.2 instead, because this is 20%. Sorry, I walked off the screen there a little bit. And then the last one, hopefully we can see this green color, 290, and we're going to multiply that by 0.1. That is pretty bad writing. And if we sum all of that up, we would end up with 331, okay? Now, there's a reason that this is happening, right? And let's just go back to looking at the data. You notice that this is significantly higher than both the simple and the moving average. So this is significantly higher. Let's just go back to the graph. And the reason that is because in the weighted moving average, we're only capturing the last 3 months of data. And if you look what's happened over the last 3 months of data, right, we are on an upward trajectory. We're on an upward trajectory. So if it's only calculating those 3 and giving the most amount of weight to observation 10, the most recent one, then you can understand that it would be significantly higher than the simple average, okay? So let's go back and let's take a look at our values. So 3 different ways of doing it. And as the forecaster, you have to decide which way would be best for you. So the simple average, again, requires all of them to be weighted the same. The moving average captures the smaller time frame, but again, weights all of the observations the same. And then the weighted moving average, you can capture as many time periods as you want to, but the idea with the weighted moving average is that you do weight differently. So not all observations are given the same value in the end calculation, okay? Now, before we go, just one point that is important about when to use averages. So in this example, because we have a fairly constant, so I'm just going to delete some of this so that we can see a little bit better. Because we have a fairly constant experience of sales over time, right? And if I was just, again, to draw this line as an average, it would probably end up being something like this. Because it's fairly constant, this is a good candidate potentially to be using an average. Again, it depends on the importance of the item to the organization, but if this is, not an A item or considered, one of the most important ones, a B or a C item, you may choose to use a simple average. Okay, but there are limitations of the averages. And mathematically, the averages are bound, and I'm just going to zoom in here. They're bound, and it is impossible to return a value greater than the highest observation. So it cannot actually do this. It can't predict something above the greatest observation. And likewise, whatever the lowest observation, if this was the lowest observation, it is not able to mathematically, it cannot produce something beyond the lowest observation. So what happens in the average is you're always going to get a value between the highest and lowest observation. Okay, in this case, that really isn't a problem because we tend to, to kind of go up and down, but we stay pretty close to an average line, okay? But imagine, let me just zoom in here. Imagine that this was your data, and I'll just get rid of, I'll get rid of some of these lines so that we can see it a little bit easier. But imagine that this was your data, and the only thing that you saw was an upward trajectory. So your lowest data point would be here, and your highest data point would be here. But you may be inclined as a forecaster to think that this is actually going to continue in an upward trajectory over time, so that in the future, you may actually want to forecast up here. An average is not able to do that, again, because the average is bound mathematically to only return a value between the lowest and the highest in the data set that it has. Okay, so it is important to look at your data and understand, okay, is it something that would fit the use of an average? And if so, then maybe a simple, a moving, or a weighted. If not, then maybe we should be looking at a different type of forecasting technique, something such as a regression line that does have the ability to predict values outside of the data set that it's considering.